Hello, so today we are going to take a look at this problem. So the summary of the problem is that binary codes of length k in a string, where essentially we want to check that all the possible binary codes of a certain length are in a string, in a given string, right? So the input here that we have are s and k, and we want to find if all the variations of the binary code of length k are in S. So here, let's say our k is equal to 2, and this is our S. So with this example, let's just first enumerate the different binary codes that we have as a result of this. So we would have 0, 0, 0, 1, 1, 0, and 1, 1. So these are the binary codes that we have. Now, for this string, we can just check, well, is this 0, 0 is in there? So 0, 1, it's there, it's here. So we have that, and then 1, 0, we have it here and here as well. And then 1, 1, we do have it here. And so we do have all of them, so we can return true. Now, if I take, let's say, 0, 1, 0, 1, well, we do have 0, 1 and 1, 0. 0, 1, and 1, 0, but we don't have 0, 0, and we don't have 1, 1, so in this case we should return false. So this is the gist of the problem. Now when we think about this, like what did we do here? We just generated all the binary codes of length k, and for each one of them we checked if it's in the string. So we can do exactly that as a brute force solution, right? So let's say in Python we could just say, let's say define here, let's say all binary codes in string, and so we will get the string in k, right? And to generate all the binary codes here, all we need to do in Python is just generate. So we know that for every k, if you take 2 to the power of k, starting from 0, we'll get all the numbers represented by the binary codes of length k, right? So, for example, if you take so 0 to 2 to the power of 2, well, you will get all the numbers that can be represented by binary codes of length 2, right? As an illustration here, this is 0 to 4, so 0, 1, 2, 3, 4. And just one thing to note is the range is exclusive here, so we don't have this. And we do, this is 0, this is 1, this is 2, and this is 3, right? And so we do have all of them. And same thing for to the power of 3. And so using this, we could just generate all the binary code numbers, and using the Python function bin, we could generate all the binary representation. So Python, if you give any number to the bin function, it will give you the binary representation. We will need to do, of course, a little bit of conversion, but we will see that later. But for now, let's just code this up in the editor and see what it looks like. Okay, so as we said in the overview, what we need to do is just go through all the possible numbers that are that have a binary representation of length k, right? So these are from 0 to 2 to the power of k. Of course, this is exclusive here. Like 2 to the power of k is not included. The last element is 2 to the power of k minus 1. And from there we could, so let's say, for example, here, let me just run this. So if we take a list that is like equal to this range, so take this range here, let's say our k equal to 2, right? And so list will contain 0, 1, 2, and 3, right? Now if we take, let's say, bin number of element at position, let's say 1, right? So you can see here it gives us this 0b1. For the element at position 2, it gives us the binary representation here. For 3, it gives us this binary representation. So you can see with this function, it returns these extra 0b here. And we don't need those because our string would be something like 1, maybe 0, 1, 0, 0, 1, like this. So as we said, we saw in the overview, it would be like this without 0b. So 0b, 01 would be 01. So we need to get rid of this, these two here. So with that, we could just use Python's slicing here and skip the 2 first elements, right? And so here, what we need to do is we want to get the binary of I, right? And skip the 2 first one. And then check if this is not in S. We want to return false, right? Except there is one small problem here with this is, so let's say for the first one, if we take the bin here, if we take the bin of the first one, you can see if we remove these 2 here, so if we remove the first 2, we have only 0, but what we actually want is something with the length of k, right? So we want a length of 2. So we need to pad zeros here with zeros at the front. So if we take this, let's say this is first, right? Just put it in a variable here. And Python has this function called zfill, which just pads a numeric string with zeros on the left to fill a field of the given width. So we need to give it the width, the desired width, which is the desired length. And in our case here, it's k, which is 2. So if we do that, you can see here we get 0, 0, which is what we want to look for. Because this one, we should return false because it doesn't contain 0, 0. It doesn't contain 0, 0. But if we had 0 here at the front, we want to return true, right? And so what we want to do here before checking is fill up with, so that we can have a substring of length k, and then check in the string. Now, if we finish and we didn't find any substring from these codes here that is not in the string, that means all of them are in the string, so we can just return true. Of course, we can simplify this here in Python using list comprehensions and just say all and just pass this here. We want all of them to be in the string, so we want all of them to be in S for I in this. So we can simplify it like that. And this should give us the same result as this here. Okay, so now let's test this use case. Let's test this solution here. Okay, so I just put down here some couple of use cases. We can add one more here, so this should return false. So a couple of assertions here, and if we run this, we can see it passes. Of course, this is not like exhaustive, but it gives you an idea of how the solution works. Yeah, so for this one, we have only 0 zeros of the binary codes of length k, so this is not, should return false. Here it contains all of them, should return true. Here we have 0, 0 missing, for example, and you get the idea. So next, let's think about how we can solve this in a more optimized way. Or at least maybe a better way than just brute forcing through. Okay, so a different way we can look at this problem, instead of looking at it from where we generate the binary codes of length k and then check in the string, we can do the reverse. We can take the substrings of length k of S and then confirm that those are all the binary codes of length k, right? And so because this is possible because the string contains only zeros and 1, right, values. And so if we take as an example, let's go with the 0, 0, 1, 1, 0, 1, 1. So this one contains all the binary codes. So instead of generating the binary codes, we can just go through the substring and put them in a set. And so that we have unique values. And if we put only unique values, of length 2, unique substrings of length 2 in the set, and at the end the length of the set is equal to so let's just call this one code set, or for example, or just substrings set, right? Substrings set. So the length of that one would be, if its length is equal to 2 to the power of k, which are all the number of possible substrings of length k, and since we put only unique substrings and only the substrings of length k, then by definition that means that all binary codes are in the string, right? And so, for example, in this one here, well, for our substrings set, we will put first, remember we are traversing by just 2, for k equal to 2, we'll be traversing just by length 2. So I'll take these two, we'll add them, we advance just one step, we do 0, 1, we add that to the set since it's not there, and then we advance again to 1, 1, we add that to the set, and then we advance again to 1, 0, we add that to the set, advance again to 0, 1, 0, 1 is already there, so we don't do anything, and then we do 1, 1, it's already there, we don't add it, and so at the end we have this, which is 4, which is exactly equal to 2 to the power of 2, which means we have all the binary codes because we have only the substrings of length 2, and and we have all the combinations, and they are unique. So by definition, that means that all the codes are in there, right? And then that's pretty much it. That's pretty much the entire solution, is just go through all the substrings of S and of length k, of course, and add them to a set, and at the end check that the length of the set is equal to 2 to the power of k. And that's pretty much it. So let's try to write this down quickly here in the editor and see if it passes the test case. Okay, so let's write down this solution that we just went over in the overview. And so we need the substring set, right? Where we will put all the substrings, unique substrings of length k from S, right? So we will need to go through the range of the length of S so that we can try all the beginnings, all the indexes of S as beginning, except we want to take only substrings of length k, so we don't want to exceed the end of S, and so we do minus k. And for Python, so that the length minus k itself is included, we need to do +1 here. And then from there, we're just going to add to the set here, we are going to add the substring of S starting from I and of length k. And then at the end here, we are going to check, make sure that substring contains all the codes, which is equivalent to the fact that its length should be equal to 2 to the power of k. And that's pretty much it. And so we could, let's test this here. And it passes all test cases. One optimization we can do is, let's say it's a long string that, for example, this one here, if we had a long string like this, right? So we knew already that it has all the codes by the time we reached it here, right? So we could optimize and exit quickly here by just checking earlier. As soon as it gets to, as soon as we get to a set of length equal to 2 to the power of k, we can just immediately return true at that point. And that's pretty much it. This should still pass, and yep, cool. Yep, so in terms of time complexity here, we can see that we have this slope here of n, and so at most we will go so we have open time, but in terms of space here, we have this substrings which has length at most 2 to the power of k, and so we have O of 2 to the power of k essentially. Yeah, and that's pretty much it for this problem. Thanks for watching, and see you on the next one. Bye.